Okay, back to what we were doing in class today. We were about to do the double angle identities. And you'll have a little bit of homework on this. It's going to be real important that you know how to deal with sine 2a, cosine 2a, and tangent 2a. This one's extremely important in Cal 2. So to derive them, sine 2a comes from sine of a plus a, and then following our sum and difference identities, where we have sine a plus b, I say sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. But of course, in this case, the angles are the same size. And so right here we actually have sine A, cosine A, plus cosine A, sine A. And so we have two of the exact same thing. So we learned that sine 2A is 2 sine of the single angle, cosine of the single angle. What that means is if I have something like, pretend like you don't know sine of 60. If 60 is 2A, then the single angle would be just 30 degrees. So I should be able to say 2 sine 30, cosine 30, and get the right answer. Sine of 30, cosine of 30. These twos cancel, and I get the right answer for sine of 60. All right, now to derive cosine 2a, we're going to have three formulas for cosine 2a. The first one we actually don't use very much, and the other two are really important. For cosine a plus b, you would say cosine a, cosine b, minus sine a, sine b. So if you have cosine a plus a, which is of course cosine 2a, that would give you cosine a minus sine a, sine a, which gives you cosine squared a minus sine squared a. So if you graph that, you would get the exact same graph as cosine 2a. In other words, a cosine graph with a period of pi. You would get that if you graph that. So we know that cosine 2a is equal to cosine squared minus sine squared, which is just kind of coincidental that it's sort of similar to sine squared plus cosine squared, but it equals something completely different. In calculus, this actually doesn't help us very much. So we really like to go ahead and change it. I can change cosine squared into 1 minus sine squared. And then bring this down. And that gives me 1 minus 2 sine squared. Use that one a lot in calculus. Or I could go back to this one. And change this one. So I have cosine squared minus 1 minus cosine squared. Distribute your negative behind the minus sign. And that gives me 2 cosine squared a minus 1. Sometimes it doesn't matter which of the three you use. And sometimes it does matter, but only in calculus. So right now you can kind of pick and choose depending on what you want to do. Like for instance, if I wanted the cosine of 60, this is 2 times 30. So for cosine 2a, I'll use this one. So I'll say 1 minus 2 sine squared of 30 degrees. That gives me 1 minus 2. The sine of 30 degrees is 1/2 squared. 1 minus 2 times 1/4. 1 minus 1/2 is 1/2. But it wouldn't have mattered if I'd used this one, or this one, or this one. But you need to know all three. So it's a unique identity in that we go ahead and write all three different possibilities. Tangent 2a, I'll just go in and give you, it's derived from tangent a plus b. It's 2 tan a over 1 minus tangent squared a. But like we talked about in class, you also could say sine 2a over cosine 2a. All right, now some examples of what you would do with these. So your homework is like, I'll list it later, but I'm doing one of your homework problems and you'll see it in assignments. On number 10, on page 390, you have a triangle given where you have theta is up here, and this is 12, and this is 5. And they ask you to find some things. A is sine theta. Sorry, that goes across. B is tan theta. C is sine 2 theta. D is cosine 2 theta. E is tan 2 theta. F is cotan 2 theta. G is secant 2 theta. And H is cosecant 2 theta. All right, so obviously sine of theta. Oh, this is a 5, 12, 13 triangle. So sine would be 12 thirteenths. Tangent would be opposite over hypotenuse. Now let's get into sine 2 theta. What's interesting here is we don't even know what theta is. They're asking us to double the angle and find the sine of an angle that we don't even know, which we'll talk more about on Friday. But I'm going to apply the identity to sine theta, cosine theta. So sine theta, cosine theta. So of this doubled angle, I actually am looking back at this theta. Sine was 12 over 13. And cosine is 5 over 13. And so this is like 2 over 1. So I multiply the top out, and I get 120 over 13. I'm 169. All right, for cosine 2 theta, you can use any of the three that you choose. You could use cosine squared theta minus sine squared theta. I'm going to use 1 minus 2 sine squared theta. So I have 1 minus 2. Sine of theta is 12 over 13 squared. Then I have to do the arithmetic. 1 minus 2 times 144 over 169. So that's 1 minus 288 over 169. Which is 169 over 169 minus 288 over 169, which gives you negative 119 over 169. If you did your subtraction. All right, so this is cosine 2 theta. This is sine 2 theta. Tangent 2 theta, you can use the formula, or you could just put sine over cosine. Sine 2 theta over cosine 2 theta, which would give you 120 over 169 divided by this, or multiplied by the reciprocal. These cancel, and you get negative 120 over 119. Then cotangent, you just flip it over. Secant, you flip this one over. And of course, cosecant, you flip the sign over. You don't really need my help with that. All right, now, one thing that's interesting that we'll talk a little bit more about on Friday is we don't even know what theta is, but we could kind of know what quadrant it would land in if we found it, because sine is positive, cosine is negative, and tangent's negative, which would mean that it would need to be in the second quadrant. So it'd be some form of obtuse angle, but we'll talk more about that later. All right, so that's one way you'll use your double angle identities. Let's pause for a minute and write them on your memo page. So on your memo page, you want to put the sum and difference identities. And the double angle identities. Okay. Double angle, sine 2a is 2 sine a cosine a. Cosine 2a is cosine squared minus sine squared, which turns into 1 minus 2 sine squared, and also turns into 2 cosine squared minus 1. You need different things at different times. And if you choose to learn tan 2a, it's 2 tan a over 1 minus tangent squared a. Sum and difference identities, I'm going to write them like this, so don't write them yet. Just watch me for a minute. I'm going to write it sine a plus b, sine a cosine b plus cosine a sine b. Sine a minus b is sine a cosine b minus cosine a sine b. But I'm going to write it on your memo page like this, so you don't have to write them down twice. So what you'll do is the top one will follow the plus sign, and the bottom one will follow the minus sign. So if you have sine a plus b, you would have this. And if you have sine a minus b, you would have that. So that way you read the top, sine a plus b gives you this. Sine a minus b gives you this. And it's a way to consolidate your answers, your identity. So I'm going to write sine a cosine b cosine a sine b. To consolidate cosine a plus or minus b, be careful of how you write this side. The top, the plus one's going to be cosine a cosine b minus sine a sine B. The bottom is going to be plus. So when you read this, if you want to write it as one unit, if you're looking for cosine A plus B, you'll have to use the top sign. If you're doing cosine A minus B, you would use the bottom sign. So it's really good notation. And then for tangent A plus B or A minus B, it goes tangent A, the top goes like this, and the bottom goes like this. Okay. All right, now another thing you'll see on your homework. So you might want to pause it while you get this on your memo page, these two boxes. All right, so I'm going to do, you're going to have some odds to do on your homework. I'm going to do number 12 back on page 390 as an example. Sine 2x plus cosine x. Now we're solving the equation. And we're doing it on the interval 0 to 2 pi. So I'm going to change this to 2 sine x cosine x plus cosine x equals 0. I'm going to factor out cosine. You always want to factor instead of divide. Then I'm going to set cosine equal to 0. And that'll give me sine x equals negative 1/2. So my answers are cosine 0, pi over 2, and 3 pi over 2. Sine's negative 1/2 at 7 pi over 6 and 11 pi over 6. Number 14. Is sine 2x times sine x equals cosine x. Sine 2x is 2 sine x cosine x times this sine x I already have equals cosine x. You'll be tempted to divide, but do not do that. Do not divide, because you'll throw out an answer. Make sure you set it equal to 0 and factor instead. So this was 2 sine squared x cosine x, and I subtracted this to the other side. I'm going to factor out a cosine. Leaves me this. Cosine x equals 0 at pi over 2 and 3 pi over 2. And this gives me 2 sine squared x equals 1. Sine squared x equals 1 over 2. Sine x equals plus or minus 1 over root 2, which is the same thing as this. So I get all 4 pi over 4 answers. And so that's the answers to 14. Let's do a cosine 2x one. What if I, just as an example, if I have cosine 2x minus sine x equals 0. I have 3 choices for cosine 2x. Okay. I'm going to choose this one because of this word right here. So that's one way I make my decision. And now I have a quadratic. So I'm going to move it all to this side. And then I'm going to factor. It's going to be plus and minus, I believe. So I get sine x equals 1/2 and sine x equals -1. So my answers are pi over 6, 5 pi over 6, and 3 pi over 2. So that's an example of how to choose what to do. All right, and then another example of something you'll have on other homework problems. Number 22 on page 390 is cosine u equals -2/3. You don't know what how big u is, but they tell you it's between pi over 2 and pi, which means that it's in the second quadrant somewhere. So our job on this is to find sine 2u, cosine 2u, and tangent 2u. And with our calculators, we actually could just push inverse cosine. It would go into the second quadrant and find our angle. Then we could double it and find the sine, cosine, and tangent of that. But we're going to do it with our calculator. We're in the second quadrant where we know x is negative and the hypotenuse is 3. Do the Pythagorean theorem and you would get square root of 5. And since we're in the second quadrant, we know that's positive. So now I can find my double angle based on the single angle u. So sine 2u is 2 sine u cosine u. Sine u is square root of 5 over 3. Cosine u is -2/3. So the answer I get, this is like over 1, is -4 root 5 over 9. All right, cosine 2u. I can use any of the three, but since they gave me this word, I'm going to use 2 cosine squared u minus 1. So I'm going to say 2 cosine squared u minus 1. I'll put in -2/3. And that gives me 2 times 4/9 minus 1, which is 8/9 minus 1, which is -1/9. So that would be cosine 2u. And then last, we want to find tan 2u. So I'm going to put sine over cosine. You would end up with -4 root 5 over 9 multiplied by the reciprocal of that. Your final answer would be 4 root 5 for tan 2u. Now what's interesting is I knew this was in the second quadrant. If you double an angle between 90 and 180, it's going to land between 180 and 360. I know the angle that I found could be anywhere from 180 to 360, but I know a little bit more about it since sine is negative, cosine is negative, and tan is positive. This must end up landing somewhere in quadrant 3. And like I said, we'll talk about that a bit more on Friday. For the quiz on Friday, I'll tell you some problems to practice. But an example of something you would have would be like this. All right, so I might ask you to solve for all or just from 0 to 2 pi. So the quiz Friday won't have any thing like we just worked. It'll be like old stuff. So you'll do it without a calculator. I'm going to change sine squared to 1 minus cosine squared, so I can get all cosines. I'm going to move it all over here so my squared is positive. And now I'm going to factor. Let's see, this needs to be 3 and 1. And this would be minus and plus. All right, on this side, cosine x equals 3. Can't happen, so that doesn't help any. Here, cosine x equals negative 1/2. So that means my angle could be 2 pi over 3 or 4 pi over 3 plus 2 pi k, where k is any integer. So you have things like that where you have to insert an identity. Make sure that if you have something like this, I don't even know if this one works out. But for instance, don't cancel out these cosines because you'd be throwing away an answer. Subtract it. And then factor it out. And then you'd find where cosine is 0 and where sine squared x equals 3, which you square root. And that one that I made up is actually impossible. But if I thought about it a little bit more, maybe you would have ended up with like square root of 3 over 2 to find some more answers. But the big word of warning there is subtract it over, don't factor it. And then you might have these things like where you have to go around more than one time. Like if I say find all the answers of like 3 tangent 3 theta equals root 3. So I'm going to say tangent 3 theta equals root 3 over 3. And then I'm going to let u be 3 theta. And let's say the instructions are 0 to 2 pi. So I know that for tan u to equal root 3 over 3, I need pi over 6, 7 pi over 6. But since this is 3 theta, I need to go around 3 complete times. This is 1 rotation. I need to go 2 more rotations. So I'm going to add 2 pi to this and 2 pi to this twice. 2 pi is 12 pi over 6. So this one's going to be 13 pi over 6. And then this one is going to be 19 pi over 6. Then add 12 pi over 6 again for 25 pi over 6 and 31 pi over 6. Now I'm going to take u back out and put 3 theta in and divide all these by 3. Pi over 18, 7 pi over 18, 13 pi over 18, 19 pi over 18, 25 pi over 18, and 31 pi over 18, which all make it between 0 and 2 pi. Let's check this one. 3 tan of 3 theta. Will that equal square root of 3? That'll be 3 times the tangent of 31 pi over 6. 31 pi over 6. The closest multiple of 6 to this is 30, which gives me 5 pi. 5 pi lands over here, and 31 actually goes one more. A pi over 6 into the third quadrant, which gives me square root of 3 over 3 positive. And so it does work. Right, and I will, on your assignments page and on Friday, I'll list the topics that are going to be on the test. And I also will provide you the answers to the homework that was due today for Wednesday on the sum and difference identities. So please look at assignments because you will find a lot of stuff there.